In this video, we will discuss the problem root to leaves path sum. Previously, this problem has been asked in companies like Amazon, Microsoft, and Google. So let us read the problem statement and see what we have to do in this problem. Problem says that we'll be given a binary tree and every node will be having a certain number, that is, every node will be having a certain value associated with it, and we have to find the sum of all the numbers that are formed from the root to leaf path. So let us see what the question is saying. If you will see this diagram, so we have been given this binary tree. Now if we will see all the paths and what are the numbers that we are generating from the root till the leaf, so you can see here, if we will follow this particular path, that is 6, 3 and 2. So this is a path from the root of the tree till the leaf, and the number basically is this one. So you have got the number as 632, because firstly you will have 6, then 3 and then 2. So this is how we have to generate the number. Firstly we have to consider 6, then 3 and then 2. So we'll have the number 632. Similarly, if we move down like this, so the number would be 6, 3, 5 and 7. Okay, so we have to keep on generating these numbers, and ultimately when we'll add all of them, for example, when we'll follow all the 4 paths, so there are basically 4 paths from the root till the leaf node. Okay, if we add all of them up, so you will see that one path will be 632, another will be 635 and 7, another will be 635 and 4, another will be 65 and 4. Now when you'll add all these elements up, then you'll get the final sum as 13997. So we have to give this particular answer as the final sum. So how can we solve this particular problem? So for solving this, let's take a very small example and see how we can solve it. So basically, let's say we are given a number. Let's say the number is 2, then we have got 3, and then we have got 5, and then we have got something like 7 here, and then we have got something like 9 here. Now if you'll see what all numbers do we have. So like you have to understand one thing, that we have to always start from the root. So let's say we start from here. So initially our number is what? Initially our number will be 2. When we start from the root node, our number will be 2 at this point. Now when I'll go down, so what will happen? The new number that generated so far would be 23. So what I need to do is always, whatever is the number that I have generated so far, I need to multiply it with 10 and then add the new digit or the new node that I'm at. Okay. For example, if you will see, initially my number was what? Initially my number was 2. Okay. Now when I move down and I move to this particular element, that is 3. So my new number should be what? Initially it was 2. So 2 into 10 plus the new node that I'm at, that is 3. So basically the new number will be 23 so far. So in order to keep on updating the number, I always need to multiply the number by 10 and add the new node that I'm at. Okay, the current node that I'm at. Basically, you can see that so far I'll be at 23 if I move down like this. And then after that, if I take left path again, so the number will be 237, 237. How can I generate 237? So the number will be number into 10, 23 into 10 plus the digit 7. So plus 7. So this is how I'll get what? By doing plus 7, I'll get 237 here. So you have to understand that whatever is the number, I have to multiply it with 10 and then add the current node value to it. Okay. So this is how we need to generate. Now, whenever we are at a particular current node, after adding it, we can move to the left child as well as the right child. And when should I add the final value in my answer? So we should add the final number in our answer when we have reached the leaf node, because whenever you reach the leaf node, then it does not have any children, so we should add the answer. When you will be starting from the root node, then initially the number would be 2. When you go down, the number will be 23, because every time what we are doing is, whatever number we are at, we are multiplying it with 10 and then adding the current node data or the value to it. Okay, so you'll be at 23. Then when you move on the left child again, then you'll be 237. The moment you reach this last node, so it is a leaf node, so that is why you will add it you will say that, okay, now one path from the root till leaf is completed, so add it in your sum. So you can have a sum variable inside it, you can add this data, so 237 would be added. Then you'll move back up from here, and then if you move on the right child of 3, then you'll encounter 9, so you'll get the number 239. So you can add 239 as well inside the answer. Okay, and after that you will go back up from here, because you have moved to the left and right child both. Then you will go back up from here, because with respect to 3 we have explored both the children. Then after that, what will happen? We'll move to the right child. The moment we move to right child, then so far the number was 2, then the new number updated would be 25 here. Okay, so 25 would be added in the sum as well. So this is how we can add. So basically the thing is that whenever we are at a particular current node, what we will do is, we'll say that the number generated would be number generated so far into 10 plus the current node or the current nodes data is what we need to add. Okay, and when should we add the final number in our sum? Whenever we reach a node which is a leaf node, such that it is not having any left and right child, then we should add that particular number in our sum. And once we have accumulated the complete sum after traversing the complete tree, then we can finally return our sum here. So let us try and code this up and see how we can do it. So basically you can also see one thing, that we have to return this in integer type. So let's quickly write the code here. Okay, so I'm writing this code in C++, but the code is very generic in nature and it will be applicable in all the languages. So let's see what we can do here. So firstly, you will say that you will generate, like you will have one answer variable, let's say int answer. Initially, you can initialize it to 0, or let's take it as sum variable. Okay, initially the sum would be nothing but 0. Then after that, what we need to do is, we need to say, we need to check that suppose if the root node is null, if the tree itself does not exist, then there will be no, there will be no sum at all. Sum would be 0. So return the sum as 0, a base like edge case that we should always check. After that, you can say that initially you will mark the number, or let's say num, as 0. Okay, then what you need to do is you need to start your recursive approach, or you need to start your traversal for the tree. So you will start from the root node itself. Okay, and then after that you'll pass the number and you'll pass your sum as well. Okay, we'll be passing the sum by reference, so any changes that I'm making to the sum variable, that will be reflected finally as well. We can also declare it globally if we want. Okay, and after this, what we will do is, like once this function is completed, then we'll write a void recursive function. And in this void recursive function, what we need to pass is, firstly we'll pass the root node of the tree. So node star root, let's mark it as current. Okay, we'll be at the current node, so we are passing it. And after that, we'll pass int number, the number that we have generated so far, and we'll pass int ampersand sum. So whatever is the sum generated, we'll pass it as well. Okay, so far, because we need to update the final answer in the sum. Now, if the current node that we are at, if it does not exist, suppose it is null, in that case, we can simply return from this particular node. Okay, if the node itself does not exist, then I cannot add its value and I will not have any left or right child. Otherwise, if this node is existing, then what I need to do is, I need to say that my number will be equal to number into 10 plus the current node's data. So current dot data is what I will add here. So current arrow data. So whatever is the current node's data, I'll add it. That is what we have discussed. Whatever was the number, suppose so far you had number as 2, so number will be 2 into 10 plus, if the digit is 3, so you'll get 3. So 23 will be the new number generated. Okay, so this is how you'll keep on generating. And you need to check that if the current node that you are at, if its left child is suppose equal to null, and at the same time the current node that you are at, if its right child is also equal to null, in such a case, what you will do here is you will basically add this particular sum. So you will say that sum plus is equal to the number. So whatever number you have generated, you will add it inside the sum. Otherwise, what you need to do is you need to call the recursion for the root's left child, and you need to pass your number, and you need to pass the sum. Okay, and similarly, you need to call the recursion for the root's right child and pass the number and pass the sum as well. So this is what you'll be doing in general. So let's write this. Now it should work fine. Let's try and quickly compile this particular code. Okay, so to see if it is working fine. Okay, so we are getting certain error. Yeah, I should not pass root. I should write current here because I have taken the variable name as current. So whatever current node I am at, I'll go to its left and I'll go to its right as well every time. Okay, now let's compile it. It is working fine for the sample test cases. Let us submit this code to check if our code is getting accepted or not. So you can see that our code is getting accepted on all the test cases. Okay, and let's discuss the time complexity for it as well. Now talking about the time complexity of our code. So basically we are traversing through each node of the tree exactly once. So it will take order of n time for us to traverse the whole tree. Okay, apart from this, the space complexity of our code will be how much? It will be order of n for our case, because I am using recursive function for traversing the whole tree. So since I'm using a recursive function to traverse the whole tree, so that would take order of n space because of the recursive stack space. I hope that you have understood this problem clearly. In case if you did, you can mention understood in the chat. Thank you for watching this video. In case if you have any doubts, you can mention them in the comments and I'll reply to them as soon as possible. Thank you for watching this video.